in this class we will understand arrays under the hood, means how the contiguous memory will get allocated for the memory for the arrays. That we will try to understand in this class, and this class is very important for you to understand. So I request you to focus more to get the most out of this class, and if you have any doubts regarding this concept, watch this video multiple times until you get the clarity. So the concept is very simple to understand. So we will what we have done is we will take these three lines of code, real world programming lines, and we will understand what happens when each line of code gets executed on the memory. So on the memory, after the execution of each line of code, what happens, that we will try to understand in this class. And this is the memory diagram that I have taken, and we have used it to this diagram in our previous classes also. So for every class we have used this memory. So this is a real world memory, which is, you can visualize this as the RAM on your computer. So now each box is a space for 1 byte of memory. Now here in the first line of code, so whenever this first line of code, what does this consist of? It is having an array A of 3 elements, and we have initialized these 3 elements with 5, 6, 7. Now whenever this initialization happens, what happens on the memory? What happens on the memory is, for these 3 elements, the memory will get allocated and it is contiguous. Means continuous memory locations will be allocated for all the elements in the array. So let's assume that randomly the computer has chosen the memory location 8 as the starting point. Now let's assume that 4 bytes will be occupied for integer. Now we are having how many integers? 3 integers are there. For each integer, if it is 4 bytes, how many memory locations are to be allocated for all the elements in the array? 4 into 3, which is 12 memory locations are to be allocated on the memory. So what happens is, let's assume that the compiler has chosen the starting byte as 8. Now from 8, 12 memory locations are to be allocated for all the 3 elements. Means these first 4 elements, 8, 9, 10, 11, these first 4 memory allocations will be allocated for A of 0, means the 0th element. And in this case, the value of A of 0 is 5. Now how this 5 will get allocated? In binary, it is 101 is the index, and the remaining all zeros, all the values are zeros. 3 means 5 zeros will be allocated, and the remaining bytes will also get allocated with zeros. So you just understand this, all these spaces will be allocated with zeros. Now what about the second element? The second element is A of 1, means the index A of 1 will be stored with the value 6. So the 6 will get stored from 12, 13, 14, 15. The memory locations 12, 13, 14, 15 will be allocated for A of 1. And in this case it is 6. So the same way the element 6 will get stored within these 4 memory locations. What about 7? The third element A of 2. And this A of 1 is for 6 and A of 2 is for 7, and the memory locations for A of 7 is 16, 17, 18, 19. So within these 4 memory locations, 4 bytes of space, the value 7 will get stored, and the binary equivalent of 7 is 100, and the leftmost bits are occupied by zeros. So this is how memory will be allocated for an array contiguously. So this continuous memory locations will be allocated for an array on the memory. So this point is very important to understand. Now generally what we will do is, while understanding the concepts in an efficient way, what we will do is, we will just change this into a simplest form. We will flip this memory locations into 3 boxes. So, and we will turn it in the horizontal direction. So this is the kind of declaration, this is the kind of visualization that we had in our previous class. So horizontal, a box, and with multiple 100 spaces has been allocated. Now in this case, this this box of three, this memory of 3 boxes is for an array A, and in the 0th location we have 5, and in the first location we have 6, and in the second location, second index location, we are having a value of 7. So this kind of visualization is very, very, very important. Now, this is the first line of code. Whenever the first line of code gets executed, this kind of changes will happen on the memory. What about the second line of code? X is equal to A of 1. Means we have to access the value stored in array with an index 1, means here it is 6 we have to access, and we have to store that value into X. So we have to get, so it is very simple. By simply giving A of 1, we are going to get the access for these 4 bytes of space. How it is done, that we will try to understand in our next class. So in this class, just imagine that whenever A of 1 is given, we are going to get the access to these 4 memory locations, and we can get the value within those 4 memory locations, and we can store it in a variable. Now what happens is, the 6 will be accessed from A of 1, and it will get stored in the variable X. Okay, so this is the second line of code. What about the third line of code? A of 2 is equal to 8. We are updating the existing value. Means in the place of 7, we are updating this with 8. Now how that can be done? A of 2, what does the value of, what is the memory location A of 2 is consisting of? Means 16, 17, 18 memory, 18 and 19 memory locations is having a value of 7 now. Now it has to be updated with 8. Now in these locations, we are going to change this value. Sorry, this is previously 7. Now we have to change this value to 8. Okay, 1000. With this, the value A of 2 value will get updated to 8. Okay, so this is how the arrays can be understood under the, this is how the arrays will get stored on the memory. So that's it for this class. In the next coming class, how the mathematical calculations are done by the compiler to access these memory locations. We had an visualization of memory, but how the compiler is going to find whenever A of 1 is given, how it is going to calculate these memory locations. So let's assume that if A of 1 is provided, how we can calculate this value 12, 13, 14, 15. These locations, we can, within these locations, we can access the data. So how that calculations are done by the compiler, that we will understand in our next coming class. So that's it for this video. See you in the next class.